Okay, hey, we are in our second part of forces today, and our concept, or I'm sorry, our assignment's actually pretty easy today. But we have a decent amount of notes to talk about ahead of time. A lot of conceptual stuff, so a lot of just trying to figure out some of the basics of things here. First up, forces are component forces. We saw that with the sketches from yesterday. All right, as we're looking at different forces that we're studying, you can break them down into their vertical and horizontal components. This can be big as we get into unbalanced forces and trying to figure out which ones are acting against each other as it's going. If the net forces acting on an object are the same, that means that they are balanced. All right, just like your chair and you are balanced against the forces of gravity right now. If the forces are unbalanced, it's going to create movement in that direction, and that's what we're going to be looking at today. Like I said, we use that term equilibrium. So when forces in a particular direction are balanced, so when you are either motionless or traveling at a constant velocity. So if you're driving down I-94 on driving 75 miles an hour, you don't feel any forces acting upon you because it is in a constant speed. There's no acceleration. All the work that's being done is just enough to keep everything moving exactly how it is, go around a sharp corner or slam on the brakes, and the story changes. Here's a look. This is a complicated look, but breaking down those forces, just like you guys drew on your worksheets yesterday. So that brings us to the laws of motion that you for sure have talked about before. We're just going to hit them again. Isaac Newton, he's a smart dude. He invented calculus. But we're going to focus on the three laws of motions that he came up with. Today, we're going to get to law number 2. The idea is that forces, masses, and accelerations are all going to be tied together. So let's dive in. First law of motion. All right. An object in motion tends to stay in motion unless acted upon by an outside force, or an object is going to stay at rest unless it's acted upon by an outside force as well. Okay, so this is the whole idea of inertia. So your inertia is your tendency to resist changes in motion. All right, things that are more massive have a larger inertia. You've known that as you're trying to push a really heavy sled or something, it takes a lot of energy to get it going. It also takes a lot of energy to stop it versus something that's very light. Factors affecting first law of motion. Yeah. Inertia, like I said, your object's resistance to motion very closely tied to its mass as it's going. Second law, that's what we want to talk about. Examples of first law. Yeah. Sorry, I want to get moving today. Second law. Second law is the one that we need to use for our worksheet, and it's the one that you're probably familiar with, and that is force equals mass times acceleration. Equation down there at the bottom. So, like I said, this should be a real basic one that we're going to get started with. So the force acting upon an object is going to be equivalent to its mass times its acceleration. All of our problems today, you're going to know 2 of those 3 variables, and you have to solve for a third as you're going. So all different examples of second law using the equation of F equals ma. You can also calculate the weight of an object using that. Remember, the force of gravity, or the acceleration due to gravity, is 9.8 meters per second. So take its mass times 9.8. That is the force, your weight in newtons as you're going. So yeah, we'll stop there. Our units for force are newtons. With the equation, there's the one to write down right at the top, F equals ma. That is far more simple than the equations that we had last unit. So I feel confident that you guys will be able to handle the worksheet just fine today. Best of luck and enjoy the rest of your day.